Hello, and welcome to today's webinar, Solutions for Ruggedizing LEDs. My name is Michael Strong. I'm the Head of Research and Development here at MG Chemicals, and today we've prepared a special presentation that's specific to the LED industry. We will be looking at some of the common challenges encountered by LEDs as well as the solutions that MG Chemicals offers. So with that, let's get started. So the agenda for today, first we start with the introduction to the light emitting diode. We'll be taking a look at some of the theoretical concepts behind the LED. And from there, we move more on to practice and some of the common challenges that our customers are coming to us with specific to exposure. So we look at how the external environment can be hazardous in terms of the longevity and light output of LEDs. Fireproofing LED drivers, of course, these can get very hot, and as a fail-safe, a lot of designers are now putting fireproofing in, so we'll go over some of the solutions that MG has. And thermal management. Thermal management is a big issue. It's a bit of a misunderstanding. A lot of people think because LEDs have improved efficiency that they don't emit enough heat to really warrant a need for thermal management, but this, of course, is not true. And MG Chemicals has a host of solutions depending on what the customer is looking for in order to prevent overheating. And then lastly, we'll look at applications of our electrically conductive adhesives specific to things like headlamps that can help prevent the buildup of frost and preserve visibility. Okay, so let's start with understanding the theoretical concepts behind the light emitting diode, or LED. So if I can draw your attention to the graphic on the bottom there, you'll see that it consists of two semiconductors or two bands that will emit light when electrons transition from the N-type. And the N-type we've represented with these blue balls. These blue balls represent free valence electrons. Okay, so the transition is from the N-type where the free valence electron transitions to a hole in the P-type conductor, which is deficient in valence electrons. When we get that transition, we emit a photon of light and heat as a byproduct of that transition. So that is the concept of an LED. And when we compare these to traditional incandescent bulbs, LEDs are much more efficient as they waste much less energy as heat. So this is why a lot of customers, both residential and commercial, are transitioning towards using LED as light sources. Now with that, what are some of the challenges that our customers are confronting us with in terms of their LEDs and not sacrificing their performance? Well, a common one is just simple elemental exposure, and that can be anything from the outside, such as rain, airborne pollution, corrosion, and over time, these of course could jeopardize the light output and the overall longevity if we find that the light itself, the light output is compromised. Fireproofing is another one, and specific to the LED driver, which is the part that governs really the free flow of power to the light itself. Critical to prevent runaway fire and flame propagation. So that is basically a fail-safe should the driver catch fire. A lot of designers now are looking to put in materials that will not propagate flame and spread the fire. Staying on the subject of LED drivers, they also get very hot during operation. So thermal management becomes a critical issue to prevent the bulbs themselves from burning out. And then lastly, we have things like snow and frost, which can accumulate over the lens, and this will subsequently reduce the light output and visibility. So those are the challenges. What kind of solutions do we present? Well, when it comes to protecting the LED dome from the exterior environment, we have a couple options, but we'll start with conformal coatings. And these are thin films that are placed over the lens to protect them from common elemental exposure like rain, corrosion, pollution. And this just ensures that the light output stays consistent throughout the lifespan of the LED. So for here we have for two main options that most of our customers are using. The 419D, which is a one-part acrylic conformal coating, and the 422B, which is a one-part silicone conformal coating. So these are clear coats, and because of their polymer structure, these will not yellow over time. So they offer very good UV resistance, also very good moisture resistance. They do not, however, offer much in terms of chemical resistance. So if they were to be exposed to chemical solvents, fuel vapors, they would degrade very quickly, and it's not a viable option. So if that's the case, then we may want to consider instead a potting solution. And again, some of our customers will coat, some of them will encapsulate their LED array with a resin. So for here we have two principal solutions, the first being the 832WC. This is a two-part optically clear epoxy potting compound that seals against moisture and will protect against chemical exposure as well. Now the added benefit of a potting compound when you compare it to a coating is that these are solid materials. So it also will protect the LEDs from physical hazards, and that can be impacts, shocks, vibrations, things like that, whereas a thin film conformal coating is not providing you this protection. Now the trade-off, of course, is that you're adding much more material and you are adding weight. So that is kind of a consideration for the designer whether they would want to encapsulate the part or simply overcoat it with a conformal coating. Conversely, we also offer the RTV615. This is a two-part silicone potting solution, which has superior UV protection, but it's also a much softer material. So if you have an environment where the LED could be subjected to thermal cycling, you may want to consider a lower modulus material like the RTV615. Okay, so next we move to the LED driver. And the LED driver are devices that are basically regulating and optimizing the flow of current and voltage being supplied to the LED, and this subsequently helps the LED from not burning out. Now, with that in mind, it's understandable that with all this potential energy flowing through the driver, that there is the potential for fire. So a lot of designers will include a flame retardant potting resin in order to prevent the spread of this fire. In other words, something that will just contain the fire to the driver and not spread throughout the rest of the device. So with that, we offer our 834 series of epoxies, which can be used to encapsulate drivers and subsequently prevent runaway fire. Here we offer four options, the 834B, 834FX, 834HTC, and the 834 BLV. These are all two-part epoxy systems that have at the very least been tested and passed the UL 94 V0 standard within our internal lab testing. They're all also fairly low viscosity compounds, so with that they're able to wet out and cover all the intricate components of the driver circuitry. Another issue within LEDs, of course, is thermal management. And as I said before, it's a bit of a misconception that LEDs don't get that hot. They still convert much of their power to heat, so it's necessary to cool the LED to ensure that it does not overheat. Problematic areas are the LED driver and then the LED itself. So the design consideration here is to interface or mate the LED surface or the heat generating surface with a heat sink using a thermal interface material. And with that, we have several different options available. To start, we have thermal adhesives, which are one or two part epoxy systems, and these offer a permanent solution. So it's a permanent fixture that you get when you use a thermal adhesive. Thermal conductivity values are pretty good at 0.8 to 1.4 watts per meter Kelvin. However, if you want something that you could be able to go back to and rework in the future, you might want to consider options like either a thermal grease or a thermal gel. Our thermal greases are one-part components, and as I said, they are easily reworkable. So if you need to change anything out in the future, you can do so quite easily. However, it does not obviously apply any adhesive strength to that interface. And thermal conductivity's values range typically between about 1 and 6 watts per meter Kelvin. And our newest line is the thermal gels. These are also one-part systems, but unlike greases, they do not leave a residue or tack to the touch. So they almost have a kind of skin to that. But the thing about the thermal gels that are its real big feature is that they are very low modulus, so they can be compressed down to a very low bond line thickness. And that gives you superior thermal resistivity when you compare them to other materials. Thermal conductivity values here range from about 3 to 6 watts per meter Kelvin. Finally, we have our electrically conductive adhesives, or ECAs. These are epoxy-based materials used for cold solder or PCB trace repair. Much like rear window defroster tabs, ECAs can be used to fabricate heat grids over headlight surfaces. Our customers use ECAs for LED headlights or on snowplows to sustain visibility during operations. Within this line, we have 4 two-part electrically conductive adhesives denoted as 8331D, 8331S, 8330D, and 8330S. These products distinguish themselves mainly through the working time and their overall conductivity. Also, we have the 9410, which is a one-part system. Its main features are its ease of use and the high precision you get when dispensing this product. Now to summarize. Light-emitting diodes, or LEDs, encounter many problems that jeopardize their overall performance and longevity, including environmental degradation, physical wear, thermal management, fire, and inconsistent light output in cold weather. Protective coatings like acrylic and silicone-based conformal coatings protect the LED lens from environmental degradation, like UV and moisture. Optically clear encapsulants provide the same safeguards with the added benefit of protection against physical hazards like shocks and vibrations. And in this presentation, we introduced both an epoxy and a silicone option. Flame retardant epoxy potting compounds can be used to fireproof LED drivers, mitigating risks and runaway fire and flame propagation. And for that, we have our 834 series of epoxy-based flame retardant epoxy compounds. Thermal interface materials like greases, adhesives, and gels displace air at the PCB heatsink interface, boosting heat flow away from the system and preventing overheating for LED circuits and drivers. And for that, we have 3 different types of compounds. We have the thermal interface adhesives, greases, and gels. And then finally, electrically conductive adhesives can be used for cold soldering, trace repair, and fabricating thermal traces in LED enclosures, which prevents frost buildup and diminish visibility. I thank you for your attention, and with that, we're now open for questions.